Here is a short tutorial to show you how to use the factor label method in chemistry. You were introduced to this method sometime prior to our extended weekend due to the snow days. This is accompanying the Packing Peanuts lab activity handout, and I want to show you how to use the factor label method to solve the same problems that you had done already using your prior methods. So let's take a look at question number 2 first. So question number 2 says, based on the measurements of this bag, approximately how many packing peanuts are there in each bag? So I'm going to start by assuming that the green bag has a total mass of 228.66 grams. Again, you might have a slightly different number, but I'm just going to be using this one to show you how to use the factor label method. So you start with the given information, which is, again, 228.66 grams, and you're asked to figure out how many packing peanuts there are in each of the bags. So, to set up the problem, you basically set up this grid system, and in this area right here, I'm going to need some kind of conversion factor. And the conversion factor in this case is going to be something that links the number of packing peanuts to mass. So earlier for this activity, you had figured out the mass of 5 packing peanuts. So the number that I had was 5 packing peanuts, and in the future I will be simplifying this as PP, has a mass of 0.76 grams, and this is the green variety. So one way to show this conversion factor is to set up some kind of ratio. So one way of doing this would be 5 pp over 0.76 grams, or I can also reverse it and say every 0.76 grams of packing peanuts is equivalent to 5 packing peanuts. All right, so these are what we call conversion factors, and they allow us to convert from one unit to another. Since my end goal is to get to number of packing peanuts, I'm going to set up my conversion factor in such a way that the mass will cancel out diagonally and I am left with packing peanuts on top. So to see how this works, you can see how using this grid system, anything on the top is being multiplied and everything on the bottom is being divided. So if I have grams on top and grams on the bottom, they cancel out. So that means in order to use this conversion factor right there, I need to choose this setup right here. So I'm going to put my 5 packing peanuts on top, 0.76 grams on the bottom, and now I am ready to actually do the math, which involves multiplying everything on top. So this is basically a multiplication sign and dividing by whatever's on the bottom. So to do that, you have 228.66 times 5 divided by the bottom number, which is 0.76. And so my answer is 1,504. And I'm just going to round that to about 2 sig figs, so my final answer is going to be approximately 1,504, which we round to about 1,500 packing peanuts. And that is my final answer. All right. So obviously, as I'm going through this, I'm showing it to you in a slower process so you can see how it works. If you use your old method, you basically get the same answer, but I wanted you to see how to use this method. So I'm going to continue on now to the second part of the question, which is how many packing peanuts are there in the red bag? So similarly, if I start over here, red, I had a mass of 116.76 grams. Set up my grid. I know earlier that 5 red packing peanuts had a total mass of 0.30 grams. So similarly, I'm going to write the 0.3 grams on the bottom, and that is the mass for 5 red packing peanuts. So same thing, I multiply across, divide on the bottom. So if I put this into my calculator, I have 116.76 times 5 and divided by 0.3, and I have about 1,900 packing peanuts. So approximately 1,900 packing peanuts. All right, so you can see here the factor label method simplifies everything. So the hardest part is recognizing what your conversion factor is going to be. You want to set it up such that your units cancel out diagonally and that you are left with the units that you want